Hi class. Today's exercise is on water quality. So last time we talked about air pollution and air quality where you guys did the skits. Now let's transition into water. So I'm going to break this lecture up into three short videos. The first one will just talk about water resources as a whole, and looking at the water cycle, how water is distributed onto the landscape. The second video will look at groundwater, so the water that is percolated into the soil, and we'll talk about pumping that water and accessing it. And then we'll look at how water is also distributed onto the landscape, specifically in South Florida. And we'll talk about some of the things that we've done to modify this water flow. And then finally, at the end, you will have a lab exercise where you will watch just a very short video and then do a bit of research looking at water availability in Los Angeles, California, and then also here in Lee County. This goes along with the PowerPoint that's on Canvas. So if you want to follow these videos with the PowerPoint, you can. But if you're happy just listening to me, that's just as fine as well. So I'm starting here in chapter 11.1, Water World. So the first topic here is something that we've talked about many times in the class, and it's just looking at the hydrologic cycle. This is the cycle that you guys have drawn since you're probably in fourth grade. So you know exactly how it is, right? We know that water evaporates, condenses into clouds, it rains onto the landscape. That water goes into rivers. Some of it percolates down into the ground. Of course, that's groundwater. And anything running off the surface through a river or just sheet flow on the landscape makes it to the ocean. So what are the sources that are actually driving the distribution of water on the planet? There's two main ones. First is the sun, because the sun causes evaporation of water. That allows the water droplets to condense into clouds. When those clouds become too heavy and supersaturated, then they precipitate down on the landscape. Second main source is gravity. So after that water falls, it needs to be pulled down physically by gravity, whether it's down from a higher elevation, down to a lower elevation, and eventually the ocean, or down through the soil, which will then become groundwater. So the sun and gravity are the two main sources of water that drive the water cycle. If you look at different ecosystems, we could divide them up based on the amount of water that they receive. So arid regions, of course, are receiving very little bit of water. Rainforests, for instance, have a rainfall quantity of over 400 centimeters per year. And there's everything in between. So something dry like a savanna or a grassland receives very little water, and as a result, they don't have much to share around. We know that the planet itself is mostly composed of salt water, so 97% is salt, leaving us a very small fraction of just 3% being fresh water, with most of that fresh water being locked up in glaciers and in ice caps. So of that 3%, only about 30% of it is available us as drinking water in the ground or in lakes, in rivers. And a lot of it is even frozen in areas like northern Canada, for instance, that are having a lot of permafrost. So the actual amount that we could use is less than 1%, making water resources a really valuable asset. We know that they provide us with several services. So supporting services would be anything like photosynthesis that plants do, or nitrogen cycle, any sort of biological cycle. These are cycles that we've already talked about. These are supporting services. Regulatory services are things like modulating climate, as it controls the global climate, removing pollutants from the air. So when we looked at air quality, we know that water droplets stick to particles in the air, and then they remove those pollutants from the air, so it cleans the air for us and removes them, and also providing things that we need, like humans, seafood, agriculture. Water is used in two ways, so either consumptive or non-consumptive. The difference between the two, of course, if you're consuming it, means that this water is often not returned back to the ecosystem, or it's too dirty to do so. A non-consumptive source would be something like a hydroelectric plant that uses the water, but then puts it back into the ecosystem. Finally, if you look at how it's distributed on the landscape, we know that water flows in drainage basins or in watersheds. This is the area the area of land that drains the water, so it eventually falls to a river or to a lake, taking very regular paths based on elevation. So if you think of a mountain, it always flows from high elevations to low elevations, either to the left or to the right of the mountain, depending on the actual geography of the landscape. So here, in the eastern part of the United States, the water is flowing mostly east of the Mississippi, down into the Gulf of Mexico. We have the Appalachian Mountains, so water would flow to the east of the Appalachian Mountains. And then the west part of the country, if you think about the Rocky Mountains, most of that flows to the Pacific Ocean off to the west. These are open water basins or watersheds, but realize that some of them are actually closed, meaning that sometimes the water doesn't actually make it to the sea. It just collects in lower lying basins and then usually evaporates out in places like the desert.